We have to find value of x that makes A the incenter of triangle. We know that the point of concurrency of the triangle bisectors of triangle is called the incenter of triangle. The incenter always lays inside the triangle. What else we have here? Because this segment YA and ZA and XA are red, it means that they are angle bisectors. So if YA segment and ZA segment and XA segment are angle bisectors, of triangle XYZ, then AM, AL and AK are equal. This we have the concurrency of angle bisectors of triangle theorem. So we have that these three segments are equal. So the incenter A of triangle XYZ is equidistant from the sides of triangle XYZ. So now to find A, we have that AM is 5x. So it means that AL is 5x too. And we have here right triangle because we have a square right here. It means that segment AL is perpendicular to ZY segment. So we have right triangle. We have two legs given. One is given by expression 5x, so we have unknown x, and we have given hypotenuse. So we can use Pythagorean theorem. Let me remind you, when we have right triangle, A, B, legs and hypotenuse C, so A square plus B square is equal C square. In our diagram, our legs are 20 and 5x. And hypotenuse is 25. So now we substitute A by 5x. We have to take to second power plus second leg is 20 to second power, because we have given that this part L X segment, LZ segment is 20 and AZ is 25. So this is equal hypotenuse, like I said, AZ is 25 to second power. So now I will left on the left side expression with unknown x. So we have 5x to second power is 25. X squared is equal 25 to second power is 6 to 5 minus 20. I will move 20 to second power to the right side, so 20 to second power is 400. So we have 25x squared is equal to 25. Now we will divide both sides by 25. So 25 and 25 we can reduce, and we have that x squared is equal 9. So x is equal plus minus 3. But we have here triangle. We have to find x, and x is the distance. Distance cannot be negative. So our solution will be x equals 3 only. Distance cannot be negative. This is my solution.